Hello, in this lesson we will learn how to work with 4-digit display. After application was launched, it's print out low state, then we can press the button. It's making internet API request to the current weather, and it's outputting the current weather through the digital display. Let's discover how it's working. First of all, let's research our display. What physical device is it and how we should to plug it to our GPIO board, GPIO extension board. So the model of our display is 346. Yeah, this is it. So it's very simple 4-digit display, looks like that, but we work with it directly without a controller. So it has 12 pins, 7 pins, I believe, 8 pins responsible for each sector of LED. So each sector of the figure, it's a simple LED and dot as well, and 4 of pins responsible for address register. So when you choosing the specific pin, you can control first, second, third or fourth figure. Let's look the data sheet. Doesn't working, no problem. So this is a data sheet. As you can see, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 8 pins responsible for each sector. And when you switching between these specific pins, you controlling. Good question, how to print out all different figures if you need to print out the number. So the LED light has a delay when it's turning on and turning off, and when you refresh all figures very fastly using literally nanoseconds delay between printing out, you can see the normal printing out like in all displays. You can see this frequency refreshing when you recording your display through any video device. I found a good article about that. So as you can see, those pins already has numbers. This is how you should to plug it, and each pin's responsible for the sector of the figure. So this pin, first pin, responsible for this sector, like a pin number 6 responsible for it's a digit cursor. For example, pin number 5 responsible for this sector, and pin number 3 responsible for dot. How you choose what sector of dot should be highlighted? You need to use these coordinates: pin 12, 9, 8 or 6. This is the physical plugging schema. So some of pins you need to use resistors. I believe it's something around 100 ohms, and pins responsible for coordinates don't need to plug through the resistors. So you can pause the video and look how it's plugging physically. Then let's go to our code. Okay, first what we need, add our display to our JSON config. We have our resources directory. Then let's copy this our config and update it with a display. Okay, lesson number 9, 4 digits display. Okay, what do we need? We need of course we need an addresses for all 12 pins. So let's do it. I don't know, maybe let's copy this array and name it displays. Okay, name 4 digits display, 7 let's sections, just for a knowledge. The model will be 3461BS-1. Then we do not have a version, we do not have everything of this, but we have pins. Pin number 1. Actually, I already have all addresses. That's all. And let's do a mockup, just a mockup for unknown display, because we can have other type of displays like HD display to printing out, so we will have a general interface to use it, but we can have it like use different implementations of it. Okay. So what we gonna do next? I want to show you, first of all, we need to update our configuration to parse it. But when I want to show you, 1 second, I'm searching the configuration, then I'm copying this class. So it's very simple. We have a brain, what's storing all data classes, and copy it. Only one thing what we should do, as you can see now, we display config. Now we will catch a runtime exception after parsing data. Oh, not now, because we didn't inject it. Okay, runtime, main class, the name. of it, 9 4 digits display. Now we will catch runtime exception. I didn't understand why it's happening before, because I set for JSON parser this ignore properties, but first of all we need to set different configuration if we don't know the type. We don't know the type in case when we didn't pass a configuration and it's returning empty configuration. So else, I believe we have an unknown type and something can return this implementation, just a markup. Okay, but anyway, we will have a runtime exception. No, we don't have, but we will have an empty configuration, as you can see. Why it's happening? Because we should to set ignore property not only for core class, but for all subclasses, subdata classes. Okay. Now we will have the second unknown display, what we can implement in the future. Okay. Now our configuration is filled and it's alive and ready for the working. So as you can see, first display was parsed and the second display was unknown model and it didn't parse it. That's all what we need. Okay. Then add, in case when we have hardware parts, the different displays, we use a general interface and different implementation of it. So, okay, let's create an interface, name it display, and what functions it could have. Output, print. We can get a number or a string, because even for digit display you can print out like a low state or something like that. It's possible with digit sectors display. So we need some incoming parameters. Out float by default is null, or string, by default is null, and we need print time, for how long we should to print out our information. Print time in millis, and by default is 0. It means a permanent printing without turning off. Now we need some function to parsing the model of our display. So let's create a companion object and name hardware model. Which model? 346 1BS-1 equals 346 1BS-1. This is our model, and we need to create a fun isConfig valid. We already has this kind of function model. We can copy it, but we need a display config. Okay, display config, the display config, yeah, like that. The same, but the same. We don't need this one, so we just copy our information. Here we can add another configurations. So yes, we just removing all not needed symbols like here, because you can write the model of your display like that, or without this, or with dot, and it still be the same model. So we need to make smart parsing to fit each model to our data. Okay, let's create, actually, well, okay, yeah, let's create an implementation of our display. Display and model 3461BS-1. Okay, then we need some incoming parameters, Pi4J, not Pi4J, Pi4J as context. From context, then we need a display config. Okay, first we need our 12 pins to control our display. Okay, let's do it. Output pins, all 12 pins should be initialized. Output like that. It's a digital output, and let's copy it. Okay, let's modify 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Now we need, for easy understanding and work with our display, so we have different type of pins. We have those 4 pins just addresses for registers, 7 pins responsible for digit, and 1 pin responsible for dot, because in your number it could be an integer or a float number. So let's split our pins by groups. different logical groups. So first list of pins will be digits cursors. Here is 2 pins for 4 pins for 4 numbers. Private Latin var digits address registers. It's a list of digital output. Then we need the second part for symbol sector cursor. Symbols address register, the same. Then we need dot divider cursors, dot divider cursors. Dot divider address cursors. Perfect. We can set the name private var because we have the name in our JSON config, just in case. We don't need it in our logic, but maybe somehow when we'll have a lot of displays, we recognizing how to printing out. So private. And we need a thread scope for multi-threading to work all the data in their own threads. Thread scope job. Okay. Is it the class what we need? Yeah, from coroutines. Okay, then init our instance of class. Build display registers. First of all, we need to fill our list with different type of pins. Private fun, build our display. Okay, the same from here. Then in try, I recommending to set pins in try catch block because it's a lot of pins. Some of pin can't work or something like that, or you have a physical damage, something like that. So, and you immediately will catch an exception. Okay, Pi4J digital output provider, it's the easier way. Create, and we need display config pin number 1, and let's copy 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Let's modify 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The same here, of course. You can't set the same pin for all your logic. Okay, and we need a catch block. It could be empty. Yeah, we need to replace it if we don't using it. And here we can set the name as well. Display config name. Then we need to fill our list. So, as you can see from this, pin number 12, 9, 8, and 6 responsible for the registers. It's addresses of our digits. So digital address register equals list of output 12, then output 9, yeah, 12, 9, 8, 6. Eight and 6. Okay. Then we need to set our, so look how it's moving from here to here, then here, then here. Let's describe it. Symbol parts starting from left bottom part arranged clockwise. Inner center part at the end of register. Okay, and let's implement it. Symbol addresses. Where's our symbol addresses? So let's just copy it, because I already investigated. So here is it. 110, as you can see, 1, 10, 11. So we're starting from here if we want to split it. 1, 10, 11, 7. 1, 10, 11, 7. So we're starting to describe our figure let addresses in our pins. And for dot divider, it's a pin number 3. Let's set it. Actually, we don't need a list for dot divider. It's just a digital output, because we have only one divider, and it's output number 3. Okay, it should work. We can check it. Then we need some function what returning our figure. Like we can say we need to print the first figure what has a address 0. We don't need to know our physical pins we work with in logic layer, or first or second or third address, and it's returning physical states. So I already prepared this function, and let's copy it, and I can show you what it's doing. So we don't need this one. Activate cursor. When we setting incoming parameter what digit we want to printing out, if it's the first figure what has address by 0, we set first digit output to high, so pin number 12 to high. It means we will work with this figure. Or then we need a last figure what we have, what has address number 3. So we set all these pins to low, but pin number 6 to high. Pin number 6, it's his figure. So all these figures set to low, and this is for high. And we setting all figures in a high frequency loop, and it's like a printing with high frequency again and again and again. And now, and how you can see all 4 figures. Then we need to map ISTI outputs, because how we know, for example, figure number 5. So this LED should be highlighted this, then number 5, number 4, and number 2. And pin number 1, 7 should be turned off. So I already created a map table, ASTI table for it. Let's copy and I'll explain. So as you can see, if our symbol char equals to 0, O, or capital O, we need to set, so when we set pin state to low, it will be turned on. When we set it to high, it will be turned off. So all pins except 5, except pin number 5, should be set to high state, to low state. Only 5 to high. Let's check it. Yes, our last symbol set to high. It's pin number 5. Let's check it. Yeah, it's pin number 5. So one more time again. If you want to turn on the section, you should to set it to low state, because you're setting register pin to high and electricity moving through the chain. If you set 2 pins to high, the LED will not work. Okay. So As you can see, we have 1 or I or capital I, 2. We have in digit display, we can print out letter L. We can print out these sectors. That's all. And for dots, it's a specific function will be. So let's implement our... Oh, I forgot one thing. We didn't extend our implementation display. Now we need to implement it. First of all, we need a real-time clock counter, because we're getting a parameter for how long it should be printed out. So we need a run time clock in millis. Then detect number divider. What it means, I'll explain. So if as incoming parameter we have like that, so only dot on the second figure should be turned on, or we can get incoming parameter like that, or like that, or like that. So yeah, we need to detect, do we have a divider and what's address of this divider. So while point cursor, if present, let's do some math. If output, because we can get some different incoming parameters, so we should to predict all cases. If we getting a float incoming parameter, let's do like that, output float rem. This is a math function. We divide our incoming parameter and track, do we have some figure after division to enable. If it's equals to, we do not have, it's an integer, it was an integer, and we're returning, for example, cursor like that, else out float to string. The easier way, transform it to string and get index of divider. Okay, then else predict and parse the case when our string is not empty. Yes, and oh, I forgot else if, sorry. Yeah. String index the same, Elsa -1. Okay, perfect. Then we need to prepare incoming data to formatted string. Prepare incoming data to formatted string. Okay, var output char array. So because we sending the symbol and getting physical pin state array for each number. The same if output float not equals to null and output float rem to double equals we just can printing out to int because it's not a float incoming parameter, then to string. Elsa output float to string. Okay. But as you can see, here is an nullable value. We disagree with it. We can set it if string is null, is not null on empty string. Elsa like that. So now it's a not nullable string. Okay. And we can get an incoming parameter like that. Very, very, very long number. So, but we have only 4 digits in our display. So we need to cut the length. Char array length more than 4. Output chat array equals output char array substring and coordinates from the first position. We need 4 chars. Okay, it's almost done. Let's create our scope. First of all, we cancel the previous job. Then we thread scope, coroutine scope, job plus dispatchers IO by tradition lunch. Then we need a cycle. So not a cycle, we need while state. This job will be implementing while our clock counter didn't finish increasing, or if we getting an as incoming parameter 0, we never turning off this thread and never destroying it. Because if you cancel the coroutine, printing out will be cancelled immediately. So first of all, some checks. If print out equals null, or print out in millis equals 0, we returning true for this while. Else, while print out in millis in our incoming parameters more or equal to our counter, and we will increase this counter after each iteration. Yeah, then we are opening our while loop, and let's printing out for each figure. So we have a for cycle for each number. We don't know how many numbers, but we don't care because we already parse it and prepared all the data. So in output char array, we already prepared it. We have indices, these functions with returning index of each existed array in the list. So to print digit, with the correct pulse voltage frequency delay. What is this? As you can see, maybe you saw it before, some old monitors, not LED displays, and old kinescope displays, when you look at it through your glasses or through the video camera, it's refreshing and blinking. So this is the frequency to updating each figure. And I did some experiments and I figured out what the frequency should be. It's a flexible, so we need a delay in millis. So the frequency depends how many figures we do have. For example, too long. For example, if we're printing only one figure, we don't need to refresh all our display. We need to refresh only this one. So we do not work with all the pins and all addresses, and we can refresh it more intensively. But if we want to refresh all figures, we need to change the frequency of refreshing. So this is the formula what I researched. General delay for refresh rate for whole display, it's 16 milliseconds, and you split it to divide it to how many figures you do have. It depends. So it's a flexible value. Then we set it okay, millis. Okay, then what we need: activate digit cursor, what is this? We asking, okay, now we will work with first sector, with first figure. Then in next loop of 4 cycle, we will say, okay, then we set second figure, then third. It depends how many figures we do have. So yes, we just asking our function, okay, now we printing out the specific sector of our display. Then we map we have an array with some symbols, and we calling, okay, like give us the printing coordinates for each figure. Then it's returning an array, and we should to use for each index and state. So for we're sending which symbol we do have, which char, and it's returning states of our pins. And for symbol address registers of index, of returning index, we returning set state to state. Then print divider if need, because we don't know, do we have a divider for it? So if point cursor is present equals or more than 0, and point cursor -1 equals E, we can set dot divider register set to low. Low means turning on. Else dot divider register set to high, means turning off. Okay, so, and here we can return true. Yeah. And what I forget, each iteration we should to increase our to int. Okay. Yeah. Then, so this is in millis and this is in millis. Okay. That's all, I believe, for this class. Then we need to add our displays for circuit board building. First of all, let's add an external function to our main thread. For example, fun display print, and here we need the same like here, but we need a display position for multiple displays as well. So display position int, by default it's equals 0. Okay, then implement this function, but before it, let's parse our displays config. I believe it's the same, a little bit the same. But not here. We forgot to add distance sensor displays. Displays of display. Okay. Displays. We can use some checks for pin 1 and pin 2. It's enough. We will understand if our configuration is valid or no. Then display is configured valid if displays add display, but we adding a specific implementation of this interface because it's describing, not here, what is it, yeah, here. So it's describing an interface, but we have an implementation for it. Then it's almost done. then describe okay, we have some incoming parameters. If display position less than 0, return false. If display position less than body displays size, okay, it means we have this position, return. We can return the Boolean state from internal function body displays display position output print, receiving output the same. And as you can see, this function return not this one, this function returning something, and we just transferring what's returning to our main thread. Also return false. Okay, I believe that's all. We can go to our main thread and call it. Okay, we already set the data, I mean an updated configuration. Before we starting to do some logic, let's just set it printing out something in our display. If type hardware types circuit board, no, S, not S like S, but like S, display print display print string like that, low state. I don't know why it's asking me something. Avatar body like that. Yeah, so then we have some listeners what's printing the temperature, and we easily can printing out after that. Okay, where is it? I lost the line. Yeah, string temp to string. Perfect. Let's launch it and verify that all code compiled without any errors, and I'm going to check how it's working. Yeah, our configuration was parsed. Looks like it doesn't working. what's happened. Let's look to our function. Okay. Let's command the string. Maybe I don't like it. Okay, let me find out what's happening, why it's not printing out. Okay, I investigated why it's not printing out. It's very easy. I made a mistake in this function. So, as you can see, hardware model name here and here, it's different. That's why the display wasn't implemented. Actually, it's good. You saw how we secure physical mistakes and errors from our JSON config. So if the configuration not for a specific hardware model, maybe it's a different pins connection and you can damage your Raspberry Pi as well. So it wasn't working because of different hardware model name. I changed it and all working as expected. In our main thread, I check it and it's printing for 3 seconds. It's 3000 milliseconds. All works as expected, and when we pressing the data, our physical temperature is printed out. I believe that's all for today. Thanks for your attention and see you soon. What I want to show you in advance, how the refresh rate works in our digital display. So I changed the delay between printing out each figure and refreshing this cycle. So I increase from the 16 milliseconds to 100, and now you can see how the technology, how all the data is outputting to the display. But yeah, it works like that. But it's not the correct refresh rate. I'll return it to the default settings.